Hey everyone. So at this point, you've worked with your tables on the first page, and we're going to debrief this part of the activity. The first thing I want you to realize is that in this graph, you can think of this line here as our x-axis, and this line here as the y-axis. So basically, we're just looking at quadrant number 1. All right, now the blue line, that's going to be our least squares regression line. Okay. And then those other two lines that kind of form a crosshair, those represent the average y value of the points and the average x value. Okay. So this horizontal line represents the average y value of the points, and this vertical line would represent the average of the x values. Okay. Meaning that where the crosshairs meet, right, that location represents the ordered pair whose values are the average x and the average y value. Sometimes we refer to this as the center of gravity. Okay. You might have noticed anytime the line adjusted, that center of gravity point, the crosshairs moved or adjusted with the line. Okay. All right, so let's go through each of the 4 points that you added on to the scatter plot. So in part A, you added a point to the very far right side. So it would have been located right about there. Okay. And the effect of that point is it essentially pulls the line down. Okay, so the right side of the line is going to tilt down, causing the left side to tilt up. So our slope decreases, the intercept increases, and the correlation, if you're keeping track of it in the applet, it's going to decrease as well. Okay. In part B, we add a point on the far left-hand side. So I'll mark the location here, label it with a B. And this essentially has the same effect. Okay? It's going to cause the left side of the line to tilt up, causing the right side of the line to tilt down. So again, the slope will decrease because the line is getting flatter, more horizontal. The intercept increases because the left side of the line is getting higher, and the correlation decreases. Okay. All right, here's the big takeaway about parts A and B. Okay, these outliers on the far right or far left both have the same effect in they tilt the line. All right, in part C, we add an outlier below the least squares regression line, so it's about this location here. And that doesn't cause the line to tilt one way or another, okay, but it does cause the line to shift down. And then in part D, we place a point at the very top, and that causes the line to shift up. Okay. So both parts C and D, in a nutshell, cause the line to shift. Okay, up or down depending on the location of where the point is placed. Okay. All right, in all 4 cases, you might have realized that the correlation decreases, gets closer to 0. Okay. And this is because all 4 points are out of the pattern. They don't follow the original pattern of those original 10 points. Okay. And so when a point is out of pattern, it weakens the correlation. Okay. So all 4 of these points would be considered outliers because they're not they don't follow the original pattern. And you can also see, we'll look at it in a moment, that they have large residuals. So for instance, point A has a large negative residual. Point B would have a somewhat large positive residual. C would have a large negative residual, and D would have a large positive residual. All right, the last question in this activity had you think about which type of outliers have the greatest impact. The horizontal ones, which would have been points A and B, or the vertical ones, which would have been points C and D. And it turns out that the horizontal ones have more of an impact because they change both the slope and the intercept. Okay, So both of these values changed. Okay. Whereas with C and D, the slope stayed the same. Okay. So more aspects of the line are changing when the outlier is in the horizontal direction. We have a special name for these horizontal outliers. We call them high leverage points. And this is a name that we kind of borrow from physics. If you think about a seesaw or a fulcrum, okay, if you put a large weight near the center of the seesaw, it doesn't do much. Okay? But if you put a large weight on the far right side or far left side, it's going to cause that seesaw to tilt on the direction that you put the weight on. And so that's where this term leverage comes from, and we were borrowing it from physics. All right, another College Board term that I'm going to introduce here is called an influential point. Okay. And so this refers to a point that if you remove it from the data set, it drastically changes either the slope, the intercept, or the correlation. I'm just going to write R instead of correlation. All right, so I've already pre-filled in the important ideas just to kind of keep this video a little bit shorter. But first we have some vocabulary terms. Okay. So outliers are points that don't follow the pattern, so they're going to have large residuals. All 4 points you saw today are considered outliers. Okay. High leverage points have either very large or very small x values. So that'd be points A and B from the activity. And influential points will cause big changes in either the slope, the intercept, or the correlation. All right, outliers and the least squares regression line. So we saw that horizontal outliers tend to tilt the line like a seesaw. Vertical outliers just cause the line to shift up or down without tilting. Okay. All right, a good least squares regression line is going to have a low S statistic. That's the standard deviation of the residuals. And it's going to have a high R squared. That's also called the coefficient of determination. Okay. Remember, S measures the typical prediction error, and R squared measures the percent of variation in the Y values that the model can explain. So we want S to be low because we want low prediction errors. We want R squared to be high because we want a high percentage of variation to be explained. Okay. Also, good LSRLs are going to have residual plots or produce residual plots that look random, that don't have any leftover pattern. All right, the last section here in the important ideas are a couple formulas which are provided to you on the official College Board formula sheet. But these formulas allow you to calculate the slope and intercept without technology, or they allows you to calculate it based off of other statistics. Okay. So to find the slope of the least squares regression line, okay, you can take the correlation and multiply it by the ratio of the standard deviations. Okay. To find the intercept, we can use this formula, but rearranged. Okay. So if we solve this formula for A, isolate A, we would get A is equal to Y bar minus B X bar. Okay. So if you take the mean Y value and subtract the slope times the mean X value, right, that result will be the intercept of the least squares regression line. All right, so I don't want you to do it right now because you guys have another activity to work on. But if there's time at the end of the period, I'd love for you to try question C here, right? Gives you an opportunity to practice using these two formulas to find the intercept and slope of the LSRL.